Hello, this is Mrs. Groves, and today we are going to be talking about another method to solve quadratic equations. And this method, we need to have our x squared term isolated and equal to some sort of a number. And there's three types of solutions. If the number is a positive number, so say for example, x squared equals 25. Well, we could have 5 squared, which is 25, or negative 5 squared, which is 25. So in that case, x squared equals 25. We get two solutions. And the solutions are going to be x is equal to whatever that number is, plus and minus, and the square root of it. If x squared is equal to 0, well, then we only have one solution. That's x is 0. And if x squared is a negative number, we can't take the square root of a negative number because it's going to be no solution, or a better way to say it is no real solution. So the easiest thing to do to understand these three types of solutions is let's do three problems. And here are the steps for this method. We're going to isolate the x squared term. So for this first example, we have to isolate the x squared term. And so we're going to add 5 to both sides. So that's going to cancel this out. I'm going to get z squared equals 9. The next step is we're going to take the square root of both sides, because the inverse operation of squared is if we take the square root of both sides, we're going to get z, okay, is equal to plus or minus, okay, the square root of 9 is 3. Okay. And when you take the square root, okay, of a positive number, your answers are going to be plus and minus. So you can have z is equal to 3 and negative 3. Okay, these are both correct answers. So the solutions are 3 and negative 3. So that was a positive number. So that's why we have two solutions. The next problem, okay, here we have to isolate the squared term. So here it's r squared. We've got to isolate that. So we are going to subtract 7 from both sides, and we're going to get r squared equals negative 3. Okay. So when we take the square root of this and the square root of this, since we cannot take the square root of a negative number, our answer is r equals no real solution. Okay, so we're not going to have a real solution. And in Algebra 1, we're not talking about imaginary numbers. So in Algebra 1, you could say R is equal to no solution. So here, I have a negative number. So I have no solutions. Now we're going to go to our third example. All right, we got to isolate k squared. We divide by 25. We divide by 25. And we get k squared equals 9 over 25. So now we're going to take the square root of this. And so we notice that 9 is a perfect square and 25 is a perfect square. So we can rewrite that as the square root of 9 over the square root of 25. And we know that, okay, and this is going to be plus or minus. So we're going to get two solutions. Okay. And so we get k is equal to plus or minus 3/5. Okay. So the solutions are 3/5 and negative 3/5. And if I were to take this number here and put it into my calculator, okay, and square it and multiply it by 25, I would get 9. So you should do calculator checks. So those are 3 examples. And this last bullet point here is check all solutions in the original equation. Right. So now I want you to try to do 3 problems on your own. All right. Again, the steps are you isolate the x squared term, take the square root of both sides, use your calculator and check all solutions in the original equation. Okay. And you should write the check for the final step to make sure that you've checked it. And you all know how to do that. So you can pause this. And I'm going to do these problems. And then you can come back and see how you did. Okay, so the first one, I have to isolate it. 108 divided by 3, x squared equals 36. Take the square root of both sides. X is equal to plus and minus 6. So, if I check x equals 6, I'm going to get 6 squared equals 108. 6 squared is 36 times 3. 108 equals 108. And it checks. And if I check x equals negative 6, then I'm going to have 3 times negative 6 squared equals 108. Negative 6 squared is 36 times 3. 108 equals 108. And it checks. Okay. So for your notes, make sure you correctly show the checks. Okay, and I'm going to count on you for your homework to use your calculator and do the checks to make sure you have the right answers. Okay, so now number 2, we subtract 17 from both sides. T squared equals 0. If I take the square root of both sides, the only answer I'm going to have is t equals 0. So notice here I isolated the squared term. I've got it equal to 0, so I only have one solution. And so if I check it, I'm going to get 0 squared plus 17 equals 17. That cancels out and I get 17 equals 17. Cha-ching, it checks. All right. The third one, we divide both sides by 81. We're going to get p squared equals 4 over 81. We take the square root of both sides, and we get p equals plus or minus. All right. And I want you to get used to, because we're going to be simplifying radicals, know that you can take this and break the numerator and denominator. So you're going to have p is equal to plus and minus 2 over 9. Okay. And when you check it, okay, and I'll do one of the checks here. All right. 81 parentheses 2 divided by 9 squared. All right. So notice I put that in my calculator. 4 equals 4. Okay, so that's what I'd like to see on your homework, that you've shown that you've checked. Okay, so that was p equals 2/9. And if I check p equals negative 2/9, well, if you have one of these nice calculators here, you can go through and you can insert that negative number. So you can see that 4 equals 4, cha-ching, it checks. Right? So here, notice that I have isolated your p squared term. And so here, that was a positive number. I got 2 solutions. That was a positive number. I got 2 solutions. That was 0. I have 1 solution. All right, so I want to continue on this discussion because I want you to understand the difference between approximate solutions and exact solutions. Okay? Approximate versus exact solutions. Okay? Approximate solutions means that we're going to have some sort of rounding taking place. Now, in many applications in the real world, we don't want to have rounding impacting, when we're constructing a road or we're doing any sort of analysis with drugs or etc. We want to have exact solutions. All right. So let's go through these two problems. So here's our original equation, and we want to round to the nearest hundredth. Okay, and the important thing is always round the final step. Okay, that's very important. You never round in the middle. So here we need to isolate the x squared term. So we're going to subtract 3 from both sides. So we get 4x squared equals 20. And then we're going to divide both sides by 4. And you're going to get x squared equals 5. Now you take the square root of both sides. Okay. When you take the square root of both sides, you're going to get two solutions, plus and minus the square root of 5. Okay. So this is an exact solution in radical form. So if you're asked to give the exact solution, you do not want to round it. And if I were to check this solution, I would get the square root of 5 squared, which is going to give me 5, times 4, which is 20, plus 3 is 23. So for the exact solution, 23 equals 23. It is going to be the exact solution. Now, here is going to be the approximate solution. So if I take and put into my calculator, okay, take the square root of 5, I got 2.236. So since I'm rounding it to 2 decimals, it's going to be approximately equal to 2.24. So these solutions are going to be, and it's plus or minus. So here we have approximately 2.24 and approximately negative 2.24. And so I want to check at least one of these answers. Okay, make sure I haven't made any mistake. And you're going to check it in the original equation. So 4, and I'm going to put 2.24 squared plus 3 equals 23. So I'm going to take 2.24, square it, times 4 plus 3, and I get 23.07 is approximately equal to 23. Since this was an estimated solution, okay, that's 2.24, this is going to be very close. It should be very close. So approximate solutions, the checks should be very close. Okay, so now I want you to pause this and do these problems yourself, and then come back and see if the work that you've done is the work that you should be showing. So I'm going to start them, and you can pause it, you work on them, and then see if I make any mistakes. So we have to isolate the x squared term. I add 7 to both sides. I get 2x squared equals 16. Divide by 2. X squared equals 8. Take the square root of both sides. So x is equal to plus and minus the square root of 8. That is the exact solution. I use my handy dandy calculator. I'm going to get x is the square root of 8 plus and minus 2.83. And so I'm going to put a little squiggly there to represent that that's an approximate solution. And to make sure that I haven't made any mistakes, I'm going to check. And here, because they're the same numbers, just opposite signs, you really only have to check one of them. So I'm going to put into my calculator 2 parentheses 2.83 close parentheses squared minus 7, and I get 9.02 is approximately equal to 9. It's very close. All right, so that one worked. So now I'm going to do the other problem. Subtract 1 from both sides. 6g squared equals 18. Divide by 6. G squared is equal to 3. Take the square root of both sides, and I get g is equal to plus and minus the square root of 3. That is the exact solution. G is approximately equal to plus and minus, okay, 1.73. And if I check that answer, I am going to put that into the calculator, and you should get 18.96 is approximately equal to 19, and there you go. So that's the end of this part of section, section 10.4. I'm going to create a second video for solving equations that are that are binomial squares. So I will be seeing you very shortly if you want to learn more about solving binomial squares. Have a nice day or a nice break.